Hello everyone, my name is Alexander Khokhlyavin, and today I'm going to talk about TindeX, which is acronym for the Time of Indexing Predictive Model, which I did during my summer internship. My mentor is Arkady Kolokutsky, and I really appreciate him for help with all of my challenges. So here you can see the table of contents we'll dive in together in this presentation. We'll start from some domain introduction, discuss our plans, going directly to the demo, take a look on pipeline and what's under the hood of our ML model, a little bit of backend, and of course, future improvements. So let's start. What we need. We should to collect data, generate some features from raw data, choose best of them, build a model, and we really want our model be able to answer questions like, is indexing time depends on using library X with Y files and projects and so on. And we want it to make predictions in seconds. Here's some disclaimer we need to worry each of you. All mathematical models are wrong, but some of them can be useful in our purposes. Interesting fact. We calculate that 22 days in total users are spending on indexing process in a week, and this is only information about 12,000 of them. A little bit surprising, huh? So what indexing is? It is a process of scanning project files during which a specific data structure is created. This data structure helps developers easily access key features of IDE products, such as code completion, full text search, and syntax highlighting. But on the other hand, indexing process is also the most time-consuming thing. It may cause some freezes, tears, and money losses. This meme demonstrates how some of our IDE users are joking on Reddit thread about how long the indexation in IntelliJ is. So here is our demo. Let's see together how it looks like. Let's start from the main page of Analytics Platform web application. Go to the upper sidebar and choose an indexation time in menu, in custom metrics menu. Then on page, let's choose a project to look at. We're currently working on IntelliJ Ultimate. We can choose version and specify build, let's say it to be this one. And we can see the results, 95% interval in which total indexing time lies. You can click on how it works link to read about the approach we use to get these boundaries. You can also see total project's absolute value, which we have according to all filters we set. We can switch between absolute values and percents on the project axis. Okay, let's add some advanced filters. Let's select Spring Core and Spring MVC libraries. Something changed. Okay. Select Mac OS in OS list Rainbow Brackets plugin. And maybe a Kotlin language in facet list. And now we see a notification that for this filter we said we haven't got enough data, and due to this, we use ML model estimation. Of course, we can change numerical parameters too. Let's set index files, for example. And at the end of our user experience, we probably want to share the results of our investigation with our colleagues by clicking the Share the Report button on the right corner. And that's it. Our colleague opens link and see exactly the same results with all filters applied. Okay, here is our pipeline. We have incoming requests, we'll filter set, then we filter real data, identify how much filtered projects we have, and if it is more than 100, we use real data to get interval boundaries. And if not, we generate new projects based on empirical distributions of each feature, then pass it through our ML model, predict target values, which is, of course, total indexing time, and get 95% interval from this data. Then we send boundaries and histogram to front end. A few words about our model. This is the decision tree with, as always, some feature-based questions in nodes and linear regression-like models in their leaves. This approach helps us to work with data subspaces and sparse feature spaces. Okay, 3 ways we select our features: by hand, automatically using greedy algorithm, and by popularity. Let's discuss a little bit validation process of our model. First of all, we select some filters config, generate some project, pass it through model, get real boundaries on the same filter set, and then identify how much of generated projects lies in a real 95% interval taken from real data. Repeat this project with different filter sets and get mean of results as an accuracy score. Backend time. We use Flask framework to build an application backend. Here are some endpoints. Models, to see full list of available models. Model/update, to use some model. Model/current, to get info about currently using model. Model/current/predict, to get indexing time based on filter set. Models current retrain, to retrain our model using new data, which is not implemented yet. Also, it's interesting to say that all front-end things configured by backend, which is generate specific config for each model we use. Of course, we have a lot of future improvements, such as adding new models, getting report summary, and many of unresolved features in our space project issue board. Going to conclusion, I want to express my huge thanks and appreciation to Arkady Kolokutskiy, Stanislav Germanovsky, Ivan Bobrov, Ekaterina Zhuvarova, Danya Brechov, and of course, all members of data analytics and analytics platform teams.